multiplying radicals involving variables. Okay, so in this case, when we have a monomial times a binomial, we simply want to distribute this using our distributive property through our set of brackets. So I'm going to take a 9 cube root 2w times a cube root 4w. Well, the coefficient in front of this radical is a 1 if nothing's there. So I'm going to take a 9 times 1, which gives me 9. A cube root of 2w times a cube root of 4w is going to give me a cube root of 8w squared. Now I'm going to take this monomial and I'm going to distribute it through my second term in the brackets. So a 9 times a 7 gives me a positive 63. I'm going to take a cube root of 2w times 28, leaves me a cube root of 56w. All right, now I'm ready to simplify. So here, 8 is already a perfect cube. W squared cannot be broken down into a product of perfect cubes. So I'm going to simply take the cube root of 8, which is 2. I'm going to multiply that by my 9, and I'm left with just a cube root w squared inside my radical. Here I'm going to break down my 56, and the perfect cube that can divide into 56 evenly is the number 8 times 7, and then we still have a times w. I can now multiply these two values, so 9 times 2 gives me 18, cube root of w squared. I'm now going to take the cube root of 8, which is 2, so I'm going to take 63, and I'm going to multiply that by 2, and I'm left with cube root of 7w inside my brackets. And then lastly, I'm going to multiply these 63 times 2, which gives me 126, cube root of 7w. And now finally you want to just glance at your radicals and determine whether you can collect these as like radicals. And we cannot. This is a cube root of w squared with a coefficient of 1. And this is a cube root of 7w, so these radicals are completely different. We are going to keep our answer as 18 cube root of w squared plus 126 cube root of 7w.